Bro,
Hey, what's up?
what is your name?
My name? This is my name. And this is my student ID. Hey,
Yes?
can you introduce yourself?
Oh, okay. This is my name. And this is my matrix number.
Hi, this is my name. This is my ID number. Present.
Geometry, originating from ancient Greek words meaning earth measurement, is a branch of mathematics concerned with the properties, relationship, and measurements of points, lines, angles, surface, and solids. Its roots trace back to ancient civilization, Egyptians and Babylonians, who used geometric principles for practical purpose, land surveying and construction. The formalization of geometry as a mathematical discipline is credited to the ancient Greeks, particularly Euclid, whose work defined geometry for centuries. Over time, geometry has evolved through contributions from Islamic mathematicians during the Middle Age. As for example, when we look at a building, the shapes and structures we see are all part of geometry. This subject is not just about drawing. It also involves solving problems and understanding how different shapes related to each other. In geometry, we learn about different types of shapes like triangles, circles, and squares, and how to measure their areas and perimeters. So in this video, we have two cases, which is tire and Kimball Art Museum.
Let me share some general information about tires. First, a tire is a circular, rubber-based component that fits around a wheel, the vehicle and the road, which is essential for safety and performance. They also help absorb shocks, providing a smoother and more comfortable ride. You will notice important tire markings on the sidewalls. This marking display details like the size. For example, 205 over 55 R16 load capacity, speed rating, and the manufacturing date. Maintaining the correct tire pressure is crucial. It improves fuel efficiency, extends tire life, and enhances safety. Lastly, underinflated tires can cause blowouts or reduce fuel efficiency, while overinflated tires can lead to uneven wear. Always ensure proper tire maintenance for optimal performance and safety. Now, let's discuss the problem statement. Here, we are working with a tire. The whole of the tire has a diameter of 34 cm, and the diameter of tire itself is 2 times the diameter of the hole. We need to calculate two things: the surface area of the tire using pi 22 over 7, and the volume of the tire also using pi 22 over 7. From the image, you can see additional measurements. The height of the tire is 60 cm, and the thickness or the distance between the inner and the outer distance between the inner and outer edges is 16 cm. Using the information, we will solve the problem step by step. On this slide, we will calculate the surface area of tire. The process involves three main steps. First, finding the surface area of the hole. Second, calculating the surface area of the entire cylinder. And lastly, determining the entire surface area by subtracting the whole surface area from the cylinder. Step 1. Surface area of the hole. First, we calculate the surface area of the hole using the formula for the total surface area of a cylinder, which is 2 pi r h plus 2 pi r square, where r is the radius and h is the height. We substitute the values. The diameter of the hole, which is d equal to 34 cm, give a radius, which is 17 cm. The height is 16 cm. After calculation, the total surface area of the hole is 3,562.2857 cm cube. After calculation, the total surface area of the hole is 3,562.2857 0.2857 cm square. Next, we calculate the total surface area of the cylinder using the same formula, which is 2 pi r dash plus 2 pi r square. Here, the cylinder's diameter is 68 cm, so the radius is 34 cm, and the height remains 16 cm. After substituting the values, the surface area of the cylinder is 10,685.7143 cm square. Finally, we subtract the surface area of the hole from the surface area of the cylinder to get the tire surface area, which is 10,685.7143 cm square minus 3,562.2857 cm square, which is we get 7,159.4286 cm square. So, the total surface area of the tire is approximately 7,159.4286 cm square. This step-by-step approach helps us accurately determine the surface area of the tire by isolating and subtracting the unwanted area of the hole.
Next, let's look at the calculation for part B, which is finding the volume of the tire. To calculate this, we use the formula for the volume of a cylinder, which is volume equal to pi r square h, where r is the radius and h is the height. The tire has two parts. The outer cylinder, which is larger radius equal to 30 cm, the inner cylinder, which is smaller radius equal to 17 cm. First, we calculate the volume of the outer cylinder. For the calculation for volume of outer cylinder is 22/7 times 30 square times 16 equal to 3,600 and 800/7 cm cube. Next, we calculate the volume of the inner cylinder. For the volume of inner cylinder is 22/7 times 17 square times 16 equal to 101,728/7 cm cube. Finally, subtract the inner /volume from the outer volume to get the tire's volume. For the volume of tire is 316,800/7 minus 101,728/7 equal to 30,724.57 cm cube. Thus, the volume of the tire is approximately 30,724.57 cm cube.
Kimber Art Museum. General information about Kimber Art Museum, located in Fort Worth, Texas, in the Cultural District. Opened in 1972, established by the Kimber Art Foundation, created by Kay and Velma Kimber. Designed by the renowned architect Louis Aihan, famous for its natural light with skylight and barrel vault ceiling, creating a serene atmosphere. Known for its small but high-quality collection of masterpieces spanning thousands of years. Features work from European masters like Michelangelo, Caravaggio, Rembrandt, and Monet. Includes art from ancient Egypt, Greece, Rome, Asia, and pre-Columbian cultures. The Kimber Art Museum officially opened on 4 October 1972. The Kimber Art Foundation, which owns and operates the museum, had been established in 1936 by Kay and Velma Kimber, together with Kay's sister and her husband, Dr. and Mr. Coleman Carter, with the appointment in 1965 of Richard F. Brown, then director of the Los Angeles County Museum of Art, as the museum's first director. The foundation began planning for the future museum and development of the collection, both of which would fulfill the aspiration of Mr. Kimber. Two aspects of the 1966 policy in particular would have the greatest impact on changing the Kimber collection: an expansion of vision to encompass world history and a new focus on building, through acquisition and refinement, a small collection of key objects of surpassing quality. The Kimber collection today consists of about 350 works that not only epitomize their periods and movement, but also touch individual high points of aesthetic beauty and historical importance. Problem statement. The Kimber Art Museum is composed of 16 parallel vaults. Each vault are 30.6 meter long, 6 meter high and 6 meter wide. The thickness of the wall is 10 cm. Find A. The total of surface area for a vault. B. Volume for all the vault. Use pi 22 divide by 7. Calculation for A. The total of surface area for a vault. The vault has a length of 30.6 meter, a height of 6 meter and a width of 6 meter. For the two outside wall, the surface area of one wall is 30.6 times 6 equal to 183.6, making total for both wall times 2 equal to 367.2. The back wall has a surface area of 6 times 6 equal to 36, and the bottom surface is 30.6 times 6 equal to 183.6. Adding this together, the total surface area of the wall is 367.2 plus 36 plus 183.6 equal to 586.8. Next, for the surface area of the roof, which has a cylindrical shape, is calculated using the formula 2 pi rh point pi r square divided by 2, where the radius is 3, which is half of the width, and the height is 30.6. Substituting this value, the roof surface area is 302.66. Finally, the total surface area of the vault is the sum of the wall and roof area. 586.80 plus 3.302.66 equal to 889.46. Calculation for B. The total volume for all vaults. The rooftop, which is a half cylinder, is calculated using the formula V equal to pi r square h divided by 2. With a radius of 3 meter and a height of 30.6 meter, the volume is 22 divided by 7 times 3 square times 30.6, and the answer divided by 2 equal to 432.7714. For the wall, model as a rectangular prism. So, the formula V equal to length times height times width is applied. Substituting the dimension 30.6 meter are their length, 6 meter for height and 6 meter for width. The volume is 30.6 times 6 times 6 equal to 1101.6. Adding this, the total volume for a single vault is 432.7714 plus 1101.6 equal to 1534.3714. Finally, for all 16 vaults, the total volume times 16 equal to 549.9424.
So we are into the conclusion. For the first case, the problem involves calculating the surface area and volume of a tire given specific dimensions. The hull of the tire has a diameter of 34 cm and the tire's overall diameter is double that of the hull. Using the given dimensions and pi as 22/7, the calculations yield the required surface area and volume. These results are essential for understanding the tire's geometry and could be applied in practical contexts, such as manufacturing or material estimation. The conclusion for the second case, the problem requires calculating the total surface area of one vault and the total volume of 16 vaults in the Campbell Art Museum. Each vault has a semi-cylindrical structure with dimension of 13.6 meters in length, 6 meter in width and 6 meter in height. Using the pi as 22/7, the calculation will provide insight into the architectural dimensions and space of museums' walls.